In this video, we're going to take a high-level look at networks. More specifically, what do they do for us, why do they matter, and how have they changed over time? So we depend on networks to transport people, goods, and information all around the world. And networks are the actual infrastructure that help facilitate moving these things from A to B. So networks themselves, though, are made up of nodes which connect to one another. And in some cases, hubs may exist, which act as places for rerouting traffic where a direct connection between nodes may not exist or is simply infeasible. Here are some examples of networks that you're likely to be familiar with. We have a transport network, a biological neural network, and we have a LAN or a local area network that you might actually be using to consume this video. So for the purpose of this course, though, we are going to focus in and drill down on information networks. That is, networks that move and store information. Here's one of my favorite examples of a network that moves information. This is the CHAP telegraph. It's also known as an optical telegraph, and it's a sequence of towers where each one is within the line of sight of another. And it can relay messages, very simple text-based messages, via adjustable arms that you can see on top. Now, each tower would also require a dedicated keeper, so it's a very labor-intensive process to communicate a message using this infrastructure. So overall, this was useful over rugged terrain where it provided more efficient communication than sending a message via horseback, for example. And in 1844, in France, there were actually over 500 of these towers that would connect 29 cities in total. Now you can see by the map there are hubs at major cities where multiple lines intersect or converge. Now this actually meant that only one line could be in use at a time. Think of someone calling you and getting a busy signal because you're already on another call. Well, imagine sending a message hundreds of miles only to have to wait for a passing message. So this certainly had its limitations, but it was useful for the time. However, it would be rendered obsolete very shortly by a more efficient method of communication. Yep, you guessed it, it was the invention of the electrical telegraph. Now, this was also enabled by widespread use of the Morse code system, which was invented by Samuel Morse just a few years earlier. And what you see on the right is, so in the very same year of 1844, Professor Morse actually sent the first long-distance message via electrical telegraph. Now, it was long distance for its time because he actually sent a message from Washington to Baltimore. So from this point onwards, there was a shift in era. A huge transition in communication was underway as humans came up with new and novel ways to harness electricity, and it would ultimately reshape our world. Now, if we compare postal speeds around the same time, we can see a huge opportunity for disruption existed should the laying of cables become economical, say, between major mail routes. I mean, look at this example. A letter between London and New York would take 12 days, whereas, electrical telegraph was near instant communication. Here is a book I recommend everyone read. I will put a link to a thread I've already done on it in the notes, but it's called Energy and Civilization by Vaclav Smil. And I'll just read a quick quote from it now. Inexpensive, reliable, and truly global telecommunications became only possible with electricity. The first century of its development was dominated by messages transmitted by wires, the adoption of the coding system invented by Morse, and the rapid extension of landlines. Now, if you're a bit young, you may have heard the term landline, but it literally just means a cable laid across land which communicates information. But once landlines were successfully installed and operated, the next frontier became laying them across water, or more specifically, submerged. This map here is of the first transatlantic cable route. Now, in 1858, it connected Ireland to eastern Canada, and it's quite famous, but unfortunately for the wrong reasons. It actually failed after only 3 weeks in service, but it did prove that communications could be sent via cables over such massive distances and underwater. So there was a lot of optimism from this point onwards. And roughly 30 years later, here is a map of major telegraph lines in 1891 all across the world. So you can see it really did spread globally very quickly. Now, part of that network was made up by a project undertaken by the British Empire known as the All Red Line. It would be completed in 1902 and it would link the empire by a system of electrical telegraphs, the majority of which were underwater, even though there were massive projects constructed across land. Now, this came at a huge expense, but think about the advantage the British Empire had at this particular time in terms of being able to communicate with all parts of its empire. Fast forward today, and the scope and scale of submarine cables across the world is staggering. Now it's built by governments and private companies alike, and it relays all kinds of information every millisecond of every day. So in the last century, we've witnessed a few major innovations in the methods we use to send and receive information, from manually delivering information from A to B, maybe by hand or horseback, to wired methods of communication, so copper wires sending electromagnetic signals or optical fibers sending light signals. And then we've evolved to wireless technologies. Now, wireless technologies obviously didn't obsolete wired technologies. They're more of a layer built on top, utilizing radio waves to transmit and receive information. So innovation regularly births new ways of sending and receiving information. And networks get built out around the methods that are significantly faster, cheaper, more accessible, more reliable, or more precise. And as I mentioned, new networks don't always replace the old. Often they're built on top of existing infrastructure in a layered architecture. And each additional layer really just increases our overall ability and flexibility to coordinate, communicate, and cooperate. And the lesson to draw from all of this is that humans are ingenious and innovation will forever continue.